Good evening. My name is Yasemin Pamuk. I'm a German diplomat and the Cultural Affairs and Science Attaché at the German Consulate General in New York. It is my pleasure to welcome you here tonight to the virtual concert lecture exploring SciArt between climatology and composition. The Scandinavian climate activist, 16-year-old Greta Thunberg has become the figurehead and voice of a whole generation's climate activism. In response, several thousand people have participated in the movement called Fridays for Future, demanding more substantial climate action from their governments and the international community. This moment helped us acknowledge that the global climate change is a fact and crucial factor that negatively impacts the lives of millions of people. Moreover, climate change is also increasingly becoming a risk multiplier that threatens the stability of countries and societies worldwide. Germany is committed to promote the role of science and evidence-based decision-making at all levels. This requires, in our view, an innovative and effective solution-based approach that follows reliable research and a comprehensive approach. Not only policymakers and scientists, but also civil society, including artists, must be equipped to take concrete action. Science diplomacy has long been a crucial part to the transatlantic relationship between Germany and the United States. By fostering exchange and collaboration between our countries, it has helped to tackle the global challenges in many critical ways. It is also a comprehensive approach that facilitates exchange and collaboration between the spheres of academia, governments, civil society, and today also that of art. In our globalizing world, we often take these partnerships as granted, but for these partnerships, we need champions. The Consulate General New York feels privileged to have such strong champions as partners. As I said before, there is no doubt about climate change and its negative effects on our planet and the lives of the people living on it. This impact ceased to be an abstract notion and has become a reality. It was, I suppose, only a matter of time that with the view to this essential challenge, the perspective of art and science have converged. I'm therefore particularly grateful to Eve O'Donnell and Lea Lukaszykau for initiating this wonderful project. Incubated as part of the Climate Week 2020, exploring SciArt between climatology and composition is an online concert and lecture bringing together many actors from art and science, the science community. I'm particularly delighted to co-host this event with the Lamont-Doherty Earth Observatory, a part of the Earth Institute at Columbia University. The event is designed to virtually explore the importance of collaboration between interdisciplinary fields to develop innovative dissemination formats of scientific research. The idea of bringing together two seemingly opposing approaches to reality may seem initially surprising. Art and science are often perceived as incompatible in their ways as they view the world, because they are mostly grounded in different educational and societal norms. The interdisciplinary and comprehensive character of this project, however, its connectivity and its approach is fascinating, as it seeks to go beyond this conventional understanding and boldly creates opportunity and space for innovative and new thinking. By supporting this event, our aim is to create synergies at the interface of science and decision-making, and foreign policy where a greater scientific voice could both add value to inclusive and comprehensive discussions, as well as to better policy decisions. It is my pleasure, therefore, to be part of this project, and the more my pleasure to hand over to Eve O'Donnell. Thank you.
Thank you, Yasemin, for that wonderful introduction. We're really thrilled to have you here with us today, and it's been an honor to work with the German Consulate to incubate both this project and explore the intersection of arts and science. So thank you for your words on the importance of, interdisciplinary collaboration. First of all, my name is Eve O'Donnell, and I'm the composer and creative producer on this project. One topic that's important and exciting to both myself and Lea Luca, who you'll meet later, is how we can explore the epistemology of innovative art-science collaborations. She did her research, some research at MIT and Harvard on the subject, and we're curious about how, both the sciences and arts can work together in an impactful way to both disseminate and communicate on important issues and find patterns on how this gets done successfully through interesting and interdisciplinary collaborations. And because of this, we initiated the SciArt collaboration with the Earth Institute, and this brings me to the speakers we have here today. So firstly, you will hear from Jacky Austermann, who is the assistant professor at the Lamont-Doherty Earth Observatory, and her presentation on the sea level change and on local coastlines in New York City. This presentation includes a music video created by both myself and Nia Luca, where we worked with Jacky to create an interplay between the music and science that disseminates her scientific research while also providing context in a joyful and takeaway format such as a music video, which I think we all need a little bit of at the moment. The second speaker you will hear today is Julius von Bismarck, internationally renowned artist and creator who has had many exhibitions internationally at prestigious locations, including his current exhibition at the Bundeskunsthalle in Bonn, with his exciting installation on Feuer Mit Feuer that speaks to his work on art and the natural world. So let's get started with the presentations on sea level change by Jacky, and I will hand the mic over to you now. And just say that I will join you again after the music video to give some points on the creative development of the composition and storyboard. And then after that, we will have a panel and some opportunity for the audience to ask our panelists, Julius and Jacky, some questions at the end. So now over to you, Jacky. Thank you.
Thank you so much, Eve. So I also want to extend my welcome to all of you, and it's exciting to see people come here. I know it's been a long Zoom world in which we live now, and definitely Zoom fatigue's kicking in, but it's really great to have so many people here today. As you've said, I'm an assistant professor at Columbia, and I am a geophysicist, and I study how sea level changes. I think about how sea level changes today in cities like New York City or cities around the world. In fact, most of humanity, or 40% of people, live along the coastlines and are affected by sea level and sea level change. But most of my research is actually not so much just looking at the little time window of today, but thinking about how sea level has changed over hundreds and thousands and millions of years. And it's a topic that really fascinates me, kind of the large interactions and changes within the climate and the Earth system. And I'm going to give you a tiny bit of that today. So while, I think about the long geologic record, of course, sea level change today and in the near future is the topic and the challenge that affects people today and that we deal with. For New York City, just to give you a bit of a sense of what magnitudes we're dealing with, I'm showing you here a graph that shows sea level change over the last century, and it shows that sea level has risen by about a foot. And it also shows you how sea level is projected to change in the future. These boxes are kind of the likely ranges in which sea level will change. And the whiskers show, so to the top and the bottom show kind of another less likely but possible range, and then the stars towards the right show you low probability but high risk scenarios. So what you see here is that sea level is projected to rise, and it's projected to rise by the end of the century by 1 meter, possibly 2, and there is even a chance that it can rise as much as 3 meters. And just for people who've lived in New York City for a while, during Hurricane Sandy in 2012, the storm surge height, so how high sea level rose for a short time period, was about 3 meters. And of course, it's had huge impacts on infrastructure, on buildings, on hospitals, on the electricity net, and on the subway, etc. So cities aren't equipped currently to deal with this amount of sea level change. So this is a challenge that we face and need to deal with. And it's a challenge that goes beyond the sciences and requires interactions with policymakers, with architects, with urban planners. And so this is today, we have the SciArt collaboration. I'll jump over to the music video in a second, but this is just a new format of experimenting, of communicating the science behind sea level change. And I know this is sort of a bleak, the way that I've motivated this is a bit of a bleak outlook into the future, but I hope that in the video, you don't just get that, but also see some of the science behind it, possibly some of the excitement and the joyful aspects of it as well, and get intrigued about the topic. And we'll take some time after the music video to dive into different scientific and presentation methods of that video. The video is about 7 minutes long, and I hope you enjoy it. And we'll switch over to Eve for the showing of the video.
Travel to destination. Walk along the coastline. Spot the outcrop. Interpret your observation. Measure the elevation. Collect the sample. Return home. Analyze the sample. Calculate sea level change. Uniform perturbation of the gravitational equipotential surface is identical to -1/a times rho I divided by rho W times the integral of delta I over the surface of the Earth plus the integral of SL times the ocean function over the surface of the Earth. Uniform perturbation of the gravitational equipotential surface is identical to where sea meets land is a constantly shifting boundary.
-1/a times rho I divided by rho -1
of evolving topography, where sea meets land is a constantly shifting boundary. When I think about sea meeting land, I think of contrast, temperature, shape, dynamics, where sea meets land is a constantly shifting boundary. Present the findings, disseminate the work.
So if we were sitting in a room right now, I would ask you which aspects of the music or the video or the presentation you picked up on or you found particularly interesting or intriguing or had questions about. Since we can't do this now, I'm just going to give you a couple of bits that I found interesting, and we'll tell you a little bit more about them, and we'll give you a little bit more of kind of dive a little bit deeper into the different aspects of the video, both on the science side and then also of how that's been translated through the music and the music video. And we're going to talk about these 4 different aspects, and we're going to start with the concept of geologic time. And throughout this, Eve and I will kind of switch off and give you both the science as well as the music and presentation as lens through which we present this topic.
Hi, Jackie. So I thought that I'd jump in here with some comments on the geologic time. And again, thank you everybody for being here and watching the video. I'm really excited to hear your comments in the Q&A section at the end. One thing that was really interesting for us was when we were exploring the timescale, the geologic timescale, it was just really interesting to understand how it gives you a history of like the whole Earth's existence. And using the geologic timescale, we created different patterns and analogies in both the video and the music. So, for example, we took the measurements and incorporated them firstly into the bars of the music and then secondly into the text setting of the piece. So these are measured patterns. They're placed in the text in the vocal line and on the timescale within the piece. For example, you may have heard the use of the word Anthropocene, and it's placed in relevant moments where it appears on the timeline that we've created, but obviously on the geologic timescale. So then just one more comment, which might be relevant to you, is that in the video, also you can see it here now on our screen at the moment, the reference to walking along the coastline, these brush strokes, which are representative of a visual geologic timescale.
Thank you so much, Eve. And this aspect of the geologic time was a really important one for me to convey, because I think when we think about, climate change and sea level change, understanding the big picture of natural variability of climate is really important. When we study the Earth's past, we learn that climate does vary naturally. There have been times when entire Earth was covered by ice sheets, and most of the time in Earth's history, temperatures are actually warmer than today. So that's by itself not unusual. What we can also learn from studying those past time periods is that whenever temperatures are high, greenhouse gases such as CO2 are also generally high. So we understand those connections between the two. And lastly, of course, we understand, which I think I'm preaching to the choir here, but that today's increase in temperatures is unprecedented. So we don't really see analogs for that in the geologic record. And we also understand why that is, and it's because of the emissions that we are pumping into the atmosphere. So having this whole geologic archive is really good for another reason, not just for context, but because we can actually use it to tackle the question of how high sea level will rise as temperatures will warm in the future, because we can ask how high was sea level when temperatures were high in the past, right? So we can go to times when temperatures were 1 degree Celsius warmer or 2 degrees Celsius. I'm glad I can use Celsius here. I'm sure many people are more familiar with that than Fahrenheit. And we can try to reconstruct how high sea level was then. And time periods that we generally go to are the last interglacial, the Pliocene, so hundreds of thousands of years in the past, or even a few million years of the past, where we have good temperature reconstructions of higher elevated values. And what we want to do as geoscientists is try to reconstruct how high sea level was in the field. And that takes us to the next of the 4 sequences, which is going into the field. And I hand it back to Eve.
Yeah, so this was really important for us to, after we started to understand how the geologic timescale works, we wanted to work with Jacky to give us kind of the instructions of what happens for her in her scientific process. And so we asked her to give us some text, and we took these instructions and recorded them into the spoken vocals and added them to both the beginning and the end of the composition. So this is a very particular method. We wanted to include it as it helps to break down the scientific process and to reflect on it. It's actually one that Leah Luca learned while working with Marina Abramovich over the summer in Germany. And it's the inclusion of instructional performance techniques embodies the possibility of alternative scientific knowledge dissemination. So it was important for us to incorporate it into this project.
Thank you, Eve. And on that note, I'm going to take you into the field with me now. We'll just look at a couple of snapshots, but I'm going to take you to one of the destinations where I do a lot of my field work, which is in the Bahamas, which is this island chain that you see here southeast of Florida. It's a beautiful place. It's a giant carbonate platform, wide beaches, which is great because it means there's a lot of sediment. And the environmental chemistry of this place is such that sand turns into rock relatively quickly. So you see this here, there are these sand dunes that essentially they are a few thousand years old, and they essentially turn into rock and are solid rock today. And this is really great for us because it's a snapshot of what the environment looked like at a past time. The specific aspect of the environment that we look for is our indicators for past sea level. And features that we look for are, for example, corals. So on the left here, you see living brain coral. On the right, you see a fossil coral that's a little bit covered by sand there. We know that this coral lives when it was alive. It was below sea level, and it was just about below sea level. And so this can provide us a pinpoint of where sea level was in the past. Here's another example. On the left, you see these beach ripples. On the right, you see very similar beach ripples that then turn into rock and are sedimentary rock today. And in fact, both of the coral and these are 125,000 years old approximately. And the corals we can actually date. So we can put our finger on sea level and we can get an age for it. And that allows us to reconstruct local sea level for these past warm periods that are sort of analogs for the future. The procedure, you've heard it in the music video. There are several steps to it. We walk along the coastline, and this is us actually there. And then we take a very close look at the outcrops from kind of the biggest scale to the finest scale of how big are the grains that we see. Are they round? Are they angular? And yes, so that leaves us with, when we return home, a reconstruction of local sea level. Now, here's where kind of one of the challenges arises, which is that we know, okay, sea level in the Bahamas was, say, 4 meters higher than it is today during this time period. However, sea level change can happen because ice is melting, but it can also happen because the land which we stand on is going up or down, right? If you're standing in New York City and you see sea level rising, by itself, everything is relative. You don't know, is that ice actually melting and there's actually more ocean volume? Or is it just because the land that you're standing on is subsiding? And a lot of my work deals with understanding land uplift and subsidence or lowering, modeling these processes. And these processes is where the kind of physical connection comes in. A lot of the equations that you heard in the video are related to modeling uplift and subsidence of the solid land. And also this equation here, which you saw, where sea level can change both if G, which is the top surface of the oceans, goes up or down, as well as if what's called R here, the solid Earth surface, so the lower bounding surface of sea level goes up and down. This is a really important concept, and you actually maybe didn't realize, but heard that a lot in the music video, because you always heard about land and sea level changes. So it's not just the sea level part. So the land aspect are very important, and they're actually quite important for New York City, which I will tell you in a second. And this brings us to part 3, the sea level equation and the physical mechanisms behind it.
Right. So once we had that kind of clear understanding of what your equations were and how they worked, it was really integral to the work and the process, and we wanted to dive in and integrate it into both the music and the text. So firstly, one of the instructions that you shared with us was a key element for the creative process, and I quote, "Where the sea meets the land is a constantly shifting boundary." And this fulcrum point was very visual and audible for me, and I wanted to kind of weave it into the instrumentation and composition. So specifically looking at the equation, you know, when you say SL equals sea level, and you know, if G or if R changes, then SL changes. And this was a very kind of this was a very pointed moment for how I was going to construct the composition. And to try and represent that, I've used the parallel thirds, sixths and ninths throughout the harmonic system to represent G, which is the surface area level. And in the voice represents R, the bedrock, which mirrors this harmony through offset counterpoint in the melody line. So another vivid moment in understanding Jacky's research was her work on local sea level change and the affecting factors of land glacier melt. Where, to explain briefly, after the land glacier melts, the land that was once impressed upon and compacted begins to move and rebound slowly long after the water is gone. So I wanted to capture this movement in the music through the counterpoint of the two instruments, and it felt like a very natural analogy for how humans are impacted by nature, and that we encounter it both while it's with us, but then also while it's gone.
Thank you, Eve. I love this because you're already explaining the science, which is fantastic. So I have a little bit of graphic to go along with Eve, what Eve just described to you, which is one of the processes that's very important for New York City, actually in particular, but around the world, that causes this land movement. And this process is related to, as ice sheets grow, they're very heavy, you know, they're huge ice sheets, they're kilometers thick, and they weigh down on the Earth's interior. The Earth deforms and sinks or lowers below the ice sheet, and areas around the ice sheet uplift. They're referred to as the peripheral bulges. It turns out that North America was covered by a giant ice sheet during the last ice age, about 25,000 years ago. Oh, this should be just 25,000 years ago. You see this giant Laurentide ice sheet here. In fact, Long Island is actually the terminal moraine of this former ice sheet. As this ice sheet melts, we have rebound in the area where the ice sheet was formerly covered land, and we have lowering of the land in the periphery of it. And we see this in the sea level records today. If you go to Canada, to Hudson Bay, for example, and you measure sea level change, you measure that sea level is actually falling. It's falling by about 1 centimeter per year. So it's falling quite rapidly, and it's falling because the land is rising out of the sea. In contrast, in New York City, we are in this region on the peripheral bulge that used to be higher and is now lowering. And therefore we see a sea level rise of about 3.5 millimeters per year. That's higher than the global average. So a significant part, about 30% of the sea level rise that we see today in New York is not just because ice sheets are melting, but it's also because the solid Earth movement. And these processes are processes that once we, have our local record in the Bahamas, need to account for in a physical and mathematical way. And this brings us kind of to the last part of how we then actually use our results and how it affects people and coastlines around the world.
Yes, so I'm going to jump back in here on this one, changing coastlines. And really now that we have that understanding of Jacky's process and her equations created from the research, we really began to have that deeper understanding of what's happening on our coastlines. There's an ongoing adjustment to the last ice age because of what happened in the past, and the Earth is still responding to the changes. So I found it very interesting when researching social science, because one of the things that it tells us is that if we want to communicate these issues, we need to appeal to core human tendencies, such as personal and local problem-solving abilities. And in the same way that local coastlines changes are different, the changes that are happening locally on these coastlines, the solutions are also different. So through this interdisciplinary collaboration, we wanted to create a compelling story that provides the information for individuals to affect the environment in a personal and positive way. And our interplay between the music and the science is created in a way to spark curiosity for self-discovery. And we hope that that's what we've done here today.
Thank you so much, Eve. We could end on that. This was such a nice closing moment, actually, but I'm going to bring back some of the earlier slides to answer some of the questions that I set up, which is, the question of how high sea level was during these past time periods. And what we find is that sea level was many meters. You see this here, 4 to 6, 5 to 20, 10 to 30 meters higher, just for modest degrees of warming. And that, in fact, is some of this sort of work informs some of these high scenarios here in the future predictions that indicate that sea level is in fact, and ice sheets are in fact quite susceptible to even modest degrees of warming. So I hope that, through this whole process and our presentation here, you look at plots like this, maybe with a slightly different eye now, understanding a little bit what kind of work might go into making such predictions, as well as why sea level in New York City is possibly a little bit higher than at other places around the world. And we, as Eve said so beautifully, we disseminating the music video ends on the note of disseminating the work. And this is what we're doing here. And this is a very integral part of, I would say, any scientific process. And I want to thank you to bearing with us through all of the sea level aspect. And with that, I'm going to hand it over to Leah-Luca, who will introduce the next segment of this presentation.
Yeah, thank you, Jackie. So from this dissemination in our collaboration, we now go over to Julius. And just to shortly introduce myself, I'm Leah-Luca, and I'm a collaborator of this project. And I'm currently doing a PhD at Cambridge University, and one of my research interests is this intersection between arts and sciences. And in this process, I was also engaging a lot with Julius. And I had an interview with him as part of my master thesis, which was very enlightening. So I thought this is a great keynote speaker for our event today. So Julius studied at Hunter College in New York City, and at the Academy of the Arts in Berlin with Olafur Eliasson. He got the Prix Ars Electronica, which is one of the most prestigious prizes on the intersection between technology and art. And then he also was one of the first, or he was actually the first artist in residence at the CERN, which is the particle physics research facility. And he exhibited his works amongst others at the Art Basel and also at the Venice Architecture Biennale. And so we are very incredibly lucky to have him here today. And so without much further ado, I would just like to hand it over to Julius.
Hello, am I on? Okay. Yeah, I'm super happy to be talking here. And we were talking before about the atmosphere and the ocean. For me, like, what is the image of the atmosphere? Like, what's the visual of the atmosphere? Super difficult. There's no really like cliche image when you say atmosphere. Like, what do you think about? And the atmosphere is what's actually heard here. The atmosphere is changed by our presence or by the presence of industrial techniques, yeah, so my work in the last couple of years was based a lot on, like, how can I find images that show something that changed. And for me, the meaning of the ocean changed dramatically. For me, the atmosphere is something completely different now. And I don't know, back then in the romantic times, like, painters changed the way we perceive nature with landscape paintings. and they changed, like they dominated for some time, and they changed our perception of how we see the landscape till now. And a lot of people think like nature has something to do with landscape, and what does the word landscape actually means. And these are things I really think are changing a lot. And there's a lot of like traditional ways of seeing this nature, and then there's scientists talking, okay, this and this is happening, we have to do something. But then there's this image of what we call nature, which has like an old tradition. So I thought, okay, maybe as an artist, it's my role to change this image, what we have, or to invent a new image, to tear down the old image of what we call nature and to invent a new one. Because the nature we are talking about now has a drastically different meaning than the one we had 100 years ago. And so that's, and then where do I start? Where is the point where like have to point my camera at, or what image is actually super relevant for this? And so the last couple of years, I thought, okay, like normally we see nature as a victim of our doing. And but sometimes nature has a power. Nature has a power to kind of do a disaster, like natural disasters. What does that mean? Like how does the meaning of natural disasters change once our position changes, like seeing, okay, nature like as something we are destroying, or we think we're destroying it, and we are destroying it. It really depends on what you accept as nature and the definition of it. And it's not so easy. So the word nature already is something that is difficult to say for me, because saying this already is believing in a certain way of understanding this. And so I'm super interested in images or in situations which have a very, how do you say in English? Like debatable, not clear meaning. And one of that was the forest fire. And like so the last couple of years I was starting with thunder and lightning, and then I went to the hurricane, and then I went to forest fires. And these were like three phenomena I was like really getting into, and trying to see, okay, what is the contemporary meaning of this? And also I did a work on the ocean, not just one work, but several works. Like, what is the contemporary ocean actually? How does it change? Like the romantic idea of the ocean 100 years ago was like this wild thing out there, like very brave seamen like went out there on boats, and sometimes they would come back and tell the stories, and they survived the big waves and everything, and they made it over, and like all this idea. Now the oceans are victims. We of the atmosphere, so the sea level is rising. We put a lot of microplastic in it, and on top in the Mediterranean Sea, a lot of refugees are dying trying to get over to mainland Europe, which completely changed for me the idea of an ocean. So like, okay, like how can you like show a painting of an ocean right now? How can you show a photo of an ocean right now? It's like not like, it has a completely different meaning. So I did a work. Maybe I switch now to a screen share. Let's see. Does it work? Do you see my screen? This is an ocean buoy. Buoys are things that are like placed out in the ocean for.
Don't see your video.
There are like signals for ships.
Julius, we don't see your video at the moment.
For orientation, they're used for radio outposts, and they're like the most like far away like symbols of human structure. And I took one of those, planted a sensor on it. So how can you exhibit the contemporary ocean? And with contemporary ocean, I mean the ocean that is not the cliche romantic idea of an ocean. It's kind of the ocean we are living in right now. The ocean that is suffering from our garbage that we throw into it, that is suffering from ice melting, it's raising up, and it's also a death trap for refugees trying to cross the Mediterranean Sea to get to a place where they think it's worth risking their life to get to. And so I did this buoy, which is like, I planted a sensor on a buoy that is on the ocean. And I took a buoy that was used from the ocean and was hanging it in the exhibition space. And they are connected. And the buoy that is hanging in the exhibition space is moving exactly like the buoy that is on the ocean. So you have a movement connection between both in real time. And the buoy is hanging on 8 steel cables that are on winches, so it can actually move in all axes, and it can completely remake all the movements the buoy on the ocean is doing. So if you come to the exhibition space, you see a buoy moving. It's just moving. It's moving exactly like a buoy is moving right now out on the sea. You don't know exactly where, but some buoy somewhere is moving exactly in the same way. And here I'm trying to like open the space, open the exhibition, open the museum for this contemporary ocean we have in mind right now. Not the one that is in paintings we saw, not the one that you see in like beautiful photos of beaches where people are enjoying themselves. Like basically what you see here is a movement which is not a normal media to show the ocean. So basically the ocean you imagine when you see it is the ocean that is affected by everything you know about the ocean. And if you are someone then spend a lot of time maybe near the Mediterranean Sea and you know about all the people that died in that, you're going to see a completely different ocean. That when you're a scientist that did a lot of research about the rise of the sea level, or you're a scientist that spends time on like analyzing how microplastic is going to affect ocean life, and or you're someone that is like an extreme like sports guy and you love surfing big waves. For this guy's ocean is something completely different. So for me, it was important to kind of introduce a new media for this, because we have a new ocean we are talking right now. It has a completely new meaning, and I want to introduce a new media for that. And that's, for me, it's movement. Yeah, I have a couple of other works, but
I think it's great because we don't have so much time, unfortunately. But I think it was a great introduction to your work, also related to sea level, and now we are with like having this idea of the contemporary ocean, what it is. So maybe it's a good starting point to introduce the panel discussion now. So actually, I would like to start with a question for Jacky, because earlier on I did an interview with Julius, and he was saying a very nice quote I would like to cite here. So he was asking, what is the output of a scientist? It's papers, and no matter what the output has has to fit into papers. And so he was stating that actually both an artist and a scientist can think about the same thing, but then the outcomes are just different ones. So the artist is doing an exhibit at the end, and the scientist is doing a paper or is publishing something. So Jacky, I wanted to ask you whether you can imagine some other alternative scientific dissemination formats.
Yes, definitely. I actually want to pick up one point that you said here in the quote to also go back to Julius's presentation, where you said that theoretically the artist and the scientist can think about the same thing, but the output of how it's presented at the end is differently. And I think that the output and dissemination is different for sure. But I think also the way of thinking about it is very different. And you might have gotten a feeling about this, how, you know, Julius's presentation is different from our presentation. I think art has a way of really engaging in a topic on a more emotional and deeper way. If you know, pictures are much easier to remember than words, right? Whereas the natural science is a lot more kind of logic based. And this is not to say, you know, one is good and the other is bad. It's just a different perception and a different way of studying it. And yeah, as a result, I think the output is also different. There is the main way of communicating our scientific results is through papers, as you say. But there are a lot of other ways of disseminating results that are, I think, being more and more encouraged. So traditionally, the scientific paper was the one and only way, but outreach and communicating scientific results to the wider public is becoming more and more important. If you write a proposal, you need to put in a section on broader impact of how your results are actually communicated. So different events, you know, or different ways of how that happens is through presentations like these, through visits through schools, engaging stakeholders directly in symposia. At Columbia, we had a meeting on managed retreat that brought in architects and urban planners. So I think there are ways of disseminating this kind of scientific work more widely. How to do this best and most effectively, I think, is a very good question. I don't have a good answer to that. This is, you know, what we're trying out here is one way of doing that. But yeah, there are lots of different ways that people try out, but it's definitely something that's being tried out more now and is definitely on the rise, especially for a topic like climate change, where this is, I think, a really important part.
Yeah, definitely. And so you were like telling us something about the dissemination and how to do that more effectively, and that we are like trying to explore those strategies actually right now. And now I would like to go back to the methodology, and I have a question for Julius. You were already like telling us a lot about romanticism or the romantic period, and then this relating to nowadays. And Peter Weibel, an artist and also the chairman of the ZKM in Karlsruhe, which is the Media Art Center, he also said that today the tools are the same. So the scientist and the artist are now also staring at the screen, whereas like in former times, the artist has a brush and the scientist had a microscope. So I would like to address that question to you, and would like to ask like whether you agree with it, and what do you think arises from that?
Yeah, I do agree. I haven't heard that quote before, but like it is the same. I do have the same tools. Sometimes I actually present myself like more as a scientist than an artist, because in areas where people like don't know what an artist is, like, okay, well, actually the work I'm doing is scientific enough to say, well, we are doing this kind of scientific whatever work. So people kind of relate to it. But sometimes it's better the other way around. So yeah, we do have the same tools, you know, like I went to Antarctica together with a couple of scientists, and they did measurements, and I was bringing a goldfish so the goldfish could swim in the Antarctic Ocean, in the Antarctic waters. So I was building a little submarine so the goldfish could swim there. So our actions were completely different, of course, because there's no scientific output of what I was doing. But it's a lot of inspired by, of course, what scientists did. And so we have the same input, but we have a different output because we have different rules for how we can output things. For an artist, there's basically no rules. Of course, there are rules. You know, you have to kind of find a way how to fit your work into the art to publish your stuff, and you have to figure out how to do that. And there might be some rules you want to follow, and there might be some rules you want to break. And yeah, as you said, a scientist normally publishes scientific papers, and an artist is publishing whatever he thinks is the right thing to publish to get over what he thinks should be, what he thinks is inspiring. That's what I think. I want to inspire people. I want to inspire people to think. I want to surprise people. I want to change people's thoughts about issues that I care about. And as a scientist, you might be like, you know, if I would be a scientist, I would probably travel to the same places that I'm traveling to as an artist. But I would take measurements, you know, like I spent months in forest fires filming very closely. The firemen that saw me were like, okay, this is not a news guy. He's not like shooting something that is supposed to be cliche of fires. He's actually really looking at it closely. So I was like, okay, I didn't know what I wanted to do. I was like, okay, I go to forest fires and I actually want to understand forest fires in a way that they were not shown before. Maybe these firemen understood them like that before, but I didn't got that. Like media wasn't transporting that to me. I was like, okay, I have to find a way to show that in a different way. And a scientist would do the same. You would go in the forest fires and look for something that maybe nobody before actually figured out. Yeah, you measure the gases that would stream out. You could measure temperatures. You could screen it with cameras that can measure temperatures. You would write all that down. You would compare hundreds of different forest fires. You would measure the rise of the CO2 level near the forest fire, which is super important. Like the Gaia hypothesis, like is actually the atmosphere able to heal itself by like over producing CO2, lowering the risk of forest fires, or is it actually increasing it? Is it like a runaway thing? Super important for scientists. Forest fires are actually a really important thing. And so I was looking for the image because the image is as important, because the scientists can find out the numbers, but actually for us to change how we act, and that's actually what's changing a lot the atmosphere, is a lot based on images. So if you don't find images that introduce a new way of understanding nature, you might not be able to sell the truths you find in the numbers, which is kind of a bit simple of how to put it. But in the end, yes, we have the same tools, we have the same subject, but I'm creating a situation in the museum, I'm creating images, a scientist publishes numbers. So that's the main difference, how we publish.
Thank you so much. Maybe one quick question from me, and then we will hand over to the audience questions. And that's also to you, Julius, because you were like displaying now that parallelism, how like artists and scientists work on, for example, forest fires, but what happens if they work together? So often, like now there's this drive to interdisciplinarity, and we all try to like collaborate, but often arts are used as a tool for dissemination, and science are used to make art like seemingly more relevant maybe. And so my question is like how we can foster like those real collaborations where you come together and create something new.
Yeah, there's many different ways for that, and I wouldn't probably there's ways of collaborating that I'm not aware of, but I know that in my last 10 years I was collaborating a lot with scientists and in very different ways. Sometimes it was like I just described, you know, I was working with lightning, and so I had to go to the place on the planet which has most lightning, and it was in a country, Venezuela, which is not so easy to do something in. So I had to collaborate with someone local that would help me to understand how things locally work. And I found a scientist which actually was doing in a PhD about that region, but in a scientific way, not in an artistic way. And so we collaborated, and he got his measurements, he got his numbers, I got my images, I got my understanding of it, and he helped me, I helped him in a very practical way. We would never need to actually talk about this. We just collaborated because we both wanted to be there. And I had some interest in this region, and I had some German money to go there. He had the interest in the region, but in the atmosphere, in measurements. And he's like, okay, well, I can make it happen. And if you bring with you some of my team along, and we make this whole scientific expedition, and you do your images and we do our measurements, and we help you with getting in, and you help us with paying for the boats and everything. So this was kind of a very, it's the first time I'm publicly speaking about this. But it was great, you know, that's how it can work. But then there's many different other ways of collaborating. You know, sometimes scientists have worked for a long time on a topic that they feel a bit frustrated about communicating to a broader public, and then they think maybe artists can actually help on that. And so there's a lot of scientists are quite often, especially scientists that work on very abstract things that are hard to communicate. So they're quite welcoming to artists, because they actually look for ways of how to make their very abstract Entdeckungen, discoveries, their very abstract discoveries actually visible for a broader audience. And I don't see myself as a tool for that, but maybe that's something I can actually help with, because I'm super inspired by the discoveries, the scientific discoveries. And then I'm like, okay, they influence a lot what my image of nature and world is, and that's kind of what I want to publish. So that's kind of a big field where collaboration helps both. And then there's many others, you know, sometimes it's fun also, you know, sometimes it's just nice to work with, it's inspiring to work with someone from a different field. And yeah, that basically every time I'm going into something like this, I'm like, yeah, I'm in Germany say they're like, you're trying to open doors, you know, the scientists are happy for an artist to come along and say, I'm doing an artwork about the exact topic you're working on. Can you help me? And they're like, yeah, for sure. I'm so happy that an artist is coming to address this issue.
Great, thank you. I think we have some questions from the audience left, so we might overrun a bit, 5 minutes or so. Eve, would you mind asking the questions?
Yes, certainly. So the first question that we have is for Julius. It's from Anonymous. But the question is, how does your artistic research process look like? How do you engage with scientific publications for inspiration for your work? And I'd also be really interested to understand your artistic research process too.
Well, there are two sides of it. One side is like directly input, which changed a lot during 2020 because I started to be a nerd again, and I discovered that a lot of scientists actually publish on YouTube, which is a good starting point to get into new topics, which actually really, opened my mind for a lot of fields that I just didn't like before. I was reading scientific magazines, which is kind of the same, but it's super nice to actually hear the scientists that published the paper talking about their own paper. And then, that really is a big inspiration for me. And it got me into fields that I wasn't really in before. And the other thing is like, what science, like where's the border of science? Like my studio, I have some people working there that are like in between science and engineers. There's something in between that, and we do a lot of works that are super complicated to realize technically, and so we sometimes have to work together with scientists to make these things happen. So the collaboration would look like you would ask a scientist, we're doing this project and we saw you publish this paper about something that is super relevant for us. Maybe you want to either join our team, or maybe we can just come over to your university and you can show us your lab and maybe get us tell us a little bit about it. This helped us a lot. So we don't have to do all the experiments ourselves, and they would show us. And so that's super nice. And and then sometimes the collaboration looks more like in a big thing. I was the artist in residence at CERN, and CERN is a big institution, and then I'm an artist in residence there. So like I got tons of interviews like from a lot of media that are asking me, okay, what is the connection between art and science? And they're like, I don't know. How do I know? I just have my very specific idea of this, and I'm not a spokesman that can decide like on this. It's just. It just shouldn't be separate just because we have a different media and we have kind of different rules of what is accepted in our field. It just doesn't mean that we have to, see it so dramatically. Normally, it just goes. It just flows. Like when I ask a scientist, "Hey, can you help me on this?" Or sometimes it's also the other way around. When I was at CERN, sometimes scientists came to me and like asked me, I always had this idea about like this artwork I wanted to do, but I don't know any artists. Like, can you tell me if it's completely bullshit or not? And I'm like, well, it's great because I'm this kind of hobby scientist and I'm kind of shy about my ideas of science. And then there's this scientist coming with his idea of an artwork, which is great, but maybe sometimes not so important for art history. Sometimes also good to just like talk, and that's important.
That's wonderful. Thank you so much. My follow-up question to that would be for your current exhibition, Feuer Mit Feuer. Do you feel like that was an important topic for you to present in your work, or does it kind of depend on whether it's your own independent project or it's when you're working with larger institutions, kind of there's a how do you become part of that decision-making process from an artistic point of view?
Well, sometimes you get asked, like, do you want to have an exhibition here? And what is your proposal? And then you come up with something that fits there. But this fire thing, I was like, after I worked with hurricanes and with lightning, I was like, I need to be in a forest fire. I have to experience burning forests. I have to be in it. I have to understand it. It's going to be like, I was sure about that. And then I just went and was stopped by the first police blockade stopping the road. Okay, how do I get around that? I figured my way around that, and like months later, I was like part of the firefighters, special forces. They embedded me, and I was just with them all the time, and it was just like it was just the work that I did is just a tiny fraction of actually what I experienced, because I'm not a journalist, and there's a lot of things I found out that would be super interesting for a journalist. I'm not a scientist, so I'm using the media I can, and I was so happy of what I could publish about that. And it's not going to be the last. I'm going to publish more about it. Like for now, it's mainly a video.
Thank you, Julius. That was so moving. And
Yeah.
just your remark there on journalism, and I've heard a lot about solutions journalism at the moment. So it's just fantastic to hear your perspective on all of these things. And we do have one last question for Jacky. Do we have time to take one more question? Maybe 2 minutes? Yeah. So from one of our audience members, Jacky, what do you think of the idea to do a residency at an artist studio and vice versa, where you switch worlds?
Thanks, Eve. Yeah, I can keep it short. So I think that it's a really interesting idea. I'd love to do that personally. As Julius was saying about his work in Antarctica, there are residency programs for artists. So if you want to go to Antarctica for an artistic purpose, you can apply for funding. There are actually programs for that. I know less of that the other way around, and I think in the end it comes also down to how our work is funded, how we're paid. I'm paid to teach, and but in theory, I think I would be really interested in it, and I think that would be really fascinating.
That's wonderful. Thank you both so much to our incredible speakers, Jacky and Julius. Thank you for being here with us this evening for incredible, engaging conversation. And also, I just want to say thank you so much to Yasemin Pamuk and the German Consulate in New York for hosting our event alongside the Earth Institute. It's been fantastic to have you all here, and goodbye for now.